a few seconds. Hey, this is Benjamin. Welcome for another virtual IoT meetup. We're very happy to have Ivan today from the PlatformIO project. You may be familiar with PlatformIO already. It's actually a very popular tool for IoT. If you're not, I guess you're going to learn more today. As always, if you have questions, please feel free to ask them on Twitter using the virtual IoT hashtag. You can also post directly on meetup.com. That's fine as well. We will be monitoring all your questions and send them to Ivan. I was actually talking to Ivan before starting, and he wants to make this very interactive. So actually, the more questions you have, the more tips and tricks you want to hear about PlatformIO. Feel free to let us know as we do the presentation, or as Ivan does the presentation, so as he can adapt and answer exactly your questions. So without further ado, Ivan, why don't you maybe introduce yourself a bit more and tell us all about PlatformIO?
Okay, thank you, Benjamin. That allowed me to be here and to have the chance to say some words about PlatformIO. 1 second, I'll open the slides. What is PlatformIO? A few words about me. As Benjamin said, my name is Ivan. I'm a founder of project lead at platformio.org. And that may be a small secret, but more than 10 years I was a web developer, and only a few years ago I switched to embedded world, and it was my home project, like home automation. And my love to electronics has started from my childhood. And if someone asked me about what was my favorite toy in the childhood, and the answer may be the simple soldering iron. And what is interesting is that I don't have deep knowledge in electronics, but when I came to this embedded world, I saw that embedded developers don't have useful instruments like we have in, for example, in web world, and PlatformIO was for me like the solution, to have one environment for the multiple boards. What do we have today in embedded world? We have a lot of different boards, also different MCU, different tool chains, SDKs, real-time operation system. And what is interesting is that in the most cases we have separate IDE, separate build scripts, separate tool chains, and finally we have different environment. And when we want, for example, to start work with new board, we should install new IDE to understand how does it work, and to spend new time on it. The second problem is community libraries, because we have a lot of different open source libraries, but the problem here is to find proper library according to hardware. For example, if I had DHT11 temperature sensor, or for example, one-wire temperature sensor, and if I'm a beginner, I don't know which version is compatible with, for example, with my frame or which my board. The third problem is operation system requirements. Some embedded vendors which produce MCUs and embedded boards, they forces users to use special IDE or special operation system, and this is a problem because some people like, for example, to work on Windows, Others like to work on Mac or Linux. And the final problem is project migration. For example, when you work in home and you are going, for example, to work, you cannot bring your project to work because you need to again install IDE or install tool chains, a lot of instruments. And together, these problems forced me to create some ecosystem where developer will have one instrument for all these things.
Ivan, sorry to interrupt. You're not sharing your slides, so can you make sure to share your slides?
Not share slides?
Yep.
Okay. 1 second. Sorry. Sorry. Do you see now?
There you go. Thank you. Perfect.
Okay, sorry. It's my mistake.
No worries.
Okay, sorry. 1 second. Do you see now?
Yes, perfect. Thank you.
Okay, sorry. It's okay. I've just talked about these problems which we have in embedded worlds, like embedded boards hardware, different tool chains, different frameworks, SDK, real-time operation system. The problem is community libraries, build scripts, requirements to operation system, and multiple integrated development environments for different vendors. What is more, that in most cases, this development environments are not free. And what is PlatformIO? Now, PlatformIO is a huge ecosystem, but in a nutshell, PlatformIO is the build system, like Make, CMake. PlatformIO is built, is written in Python and built on the scones utility, which is make the platform to be cross-platform, and PlatformIO works everywhere: Windows, Mac, Linux, and Linux, ARM, v6, v7. PlatformIO doesn't depend on operation system software. As I said, only one requirement is Python. Today, PlatformIO ecosystem covers all these problems, like the problems with library management, like to create project and to make better integration with continuous and IDE. Also, PlatformIO is fully compatible with Arduino and ARM-based mbed framework. And PlatformIO is open source project and is free for the end user and for business too. Today, we have support for more than 250 embedded boards, also for more than 20 popular development platforms, such as Atmel, also this interesting like FPGA lattice, like Tinsy, also the support for more than 10 different frameworks. You see here. And how does PlatformIO work? We can split PlatformIO into 3 parts. The first part is package manager, which is responsible to download appropriate tool chains, frameworks, uploader tools. The second part is builder, which is based on these cons, and third part is uploader. It depends on the type of the board. As I said, PlatformIO is the command line utility, but it can be integrated into the multiple IDE, and also could be integrated with continuous integration system, like Subcommander, Kravets CI, and also could be used for cloud component. For example, developer can create, for example, web IDE, but use PlatformIO for compiling and for code for firmware uploading. Also, PlatformIO has built-in serial port monitor, automatic firmware uploading, and I propose to to show how PlatformIO will work with Eclipse and create, for example, the first Blink project, like Hello World project, but in embedded we called it like Blink, to blink with the LED, built-in LED. 1 second, switch. Okay, I have a few different boards like ESP8263 not MCU, Arduino Uno, and like mbed compatible STM32. And for example, let's create the project for a few boards and upload firmware to these boards. I will use Eclipse IDE. Let's start it. Eclipse IDE, and I will show from the scratch how to initialize new project, import into Eclipse IDE, and upload, and finally upload firmware. 1 second, Eclipse starts. I will switch. Yes, we have, here is the latest Eclipse IDE. Now, as I said, PlatformIO is the command line utility, and we have 2 commands in the shell. Like full command is PlatformIO. Sorry. PlatformIO. Very well. And also a short version like ls-pio. PlatformIO can be easily installed via pip, Python package manager, pip, install. I have installed it, and we will use my version. Let's take a look on the PlatformIO top-level commands. We have the boards. These subcommand boards allow us to find appropriate board ID. For example, if you have Arduino Uno, sorry. We see it like the type of the board Uno. We will need later this board ID for project initialization. Also, we have init subcommand, which we will use, lib, it's library manager, and platforms. And let's create project for the Eclipse. I will go to temporary folder. Let's create, for example, change directory to PlatformIO, and now create PlatformIO init ID Eclipse, and let's initialize project for board Uno and the second board. We can leave only one board. We can specify 10, 20 matter board, not MCU. PlatformIO asks us to verify that all is right, and it says that PlatformIO in its project configuration file, which we should edit, and if we want, and specify extra configuration. SRC folder is aimed where we should place our source code, and library folder will be interested for developers which are going to place, for example, private libraries or libraries from master repositories. Oh, okay, 1 second. The problem here is that I deleted totally all toolchains from my system to show user on the practice how PlatformIO works from the scratch. And now we see that we initialize project for the Arduino Uno, and not MCU. Arduino Uno is based on Atmel AVR MCU, and we see that PlatformIO's package managers automatically install for us toolchains, Atmel AVR, and now we see that it downloads. Sorry, again, see that we have some problem with this speed, and now PlatformIO installs toolchain for Xtensa platform. This ESP8260 core. Backend, second, and finish. Now we go to Eclipse, import. Sorry. I will show user that we have library folder, PlatformIO IDE, and source folder. Now import existing project. Temp. PlatformIO project. What is PlatformIO INI? PlatformIO INI is the core of PlatformIO command line utility for the builder. It's the configuration file where we specify a different environment. It means that the source code, which will be located in the source folder, which we built for the different environment. For example, for the Arduino Uno, for the Node MCU, we can add here a more border like TNZ, and the end developer is responsible to write cross-platform code for the building. Now let's create I will use the quick start from our documentation and grab the Blink source code. Oops, no. I don't know why it's red. No problem. It's here we have different targets. When PlatformIO generates project for the Eclipse, it uses make targets to call own command line utility. It doesn't use make utility like edit. We see here that will be called PlatformIO with the subcommand run. Sorry, I don't know why it's sorry. It's red. Maybe refresh project. 1 second. Sorry, 1 second. No, Eclipse doesn't like me. Okay, no problem with this red one. Let's build the project. And we see that the first environment has finished for the 3 seconds. The second environment finished. Now let's upload. And what is interesting is that we have ability to use make targets from this perspective. Also we can use PlatformIO command line interface, like for example to clean project, to call target clean, or again to view project, the same as we call from here. The PlatformIO command line allow us to call specific environment. For example, in this case, when we call PlatformIO build, it will build all environments, like for the UNO and not MCU. But if you want to build for the one, we have two options. The first, to run manually and specify, for example, UNO. Other way, we can tell PlatformIO which environments should be used by default. Okay. And in this case, this is not MCU. Now, let's upload firmware to the boards. I connect two boards to my Mac. Second. And let's comment. We'll try to upload in the one time to two different boards. Upload. Second, we see that it's uploads to Arduino Uno. Oh, sorry. Writing flash. And boards blinks, but not flashing. So the indicator off. Okay, now boards blink. I don't know. I have to show. I will show one second. I will share the screen. Like different boards, oops, they blinks, and I'll back again to the Eclipse. Second. And the summary from the Blink project. What is interesting here is that we can copy only these two files, like PlatformIO IDE and main CPP, and move to any operation system, and reproduce this code without any problem. PlatformIO has pre-built different toolchains for the popular operation system, as I mentioned before, like Mac, Linux, and Windows. The behavior of PlatformIO command line utility is the same on this operation system. I mean that this command line works everywhere on the same behavior. And I want to show the second example is ESP. Now, we will, okay, from my init the Eclipse. CU2. And I will use the example from the ESP8266 project, like Wi-Fi scan. Wi-Fi, second. And let's replace this code with this. Sort here. refresh the project. Okay, please wait a few seconds. C++ indexer in progress, because we have changed our project from Atman to expressive development platform, and in this case, PlatformIO regenerated the project, also updated tool chains. Now we can use the completion also, and go to declaration like price. Click. And this example, using this example, we will show how does work PlatformIO server port monitor. We will upload this example to ESP8266 board, which has Wi-Fi on the board. Let's build.
So in the meantime, if there are any questions for Ivan, you can tweet using the virtual IoT hashtag, or you can also comment on meetup.com for sending any questions to Ivan.
1 second, we upload the firmware. Second. Now, while PlatformIO is uploading firmware, we will show small help documentation for server ports monitor. Server port monitors is very powerful. It's highly customizable. You see this firmware is uploaded. Now let's connect to our board. Oh, sorry. Need to change baud rate, because here we have this baud rate, and by default is other baud rate is used now. Like this is example. It just scans Wi-Fi networks around the boards, and here that we have like 4 Wi-Fi networks, and in the next example we will use this network, and I will demonstrate how to make firmware uploading using Eclipse over the air without any cables. In this case, 1 second, I will change. 1 second. We'll change this code, this over the air code. Change ID of the password, reset password. Okay, and upload. Now I will, while uploading is in progress, I will find other example. For example, again, the blink. And 1 second. Done. Let's connect to the board. Second. We see that our board now is listening on the AP2. Now let's replace again our code, for example, with again this blink, no problem, no problem. This blink, and now we will try to upload firmware to this board, but in PlatformIO IDE, we will specify the board, the IP of the board, and upload. We see waiting progress here, loading. Done. Board again blinks. Now I propose to back to our slides and to say something about PlatformIO Library Manager. 1 second. Benjamin, do you see slides now?
Yep.
Good. The second feature of PlatformIO ecosystem is library manager. What do we have here? We have created a manifest like library JSON. It's very close to package JSON, like web developers have this near NPM package manager. Library JSON allow embedded developers to specify or even to declare which source code from the repo from the archive should be used for the compilation, and to specify the compatibility with the frameworks, with the platforms. PlatformIO has own crawler which monitors different libraries in internet and gather them into one registry where the embedded developer can search for library using command line interface or our web interface. This is the look of two different libraries, but I propose back again to our site and to show in the practice how library manager works. Okay. Here is PlatformIO libraries registry. Here we have recent libraries like updated, added. All libraries are tagged by different keywords like sensor, displays, LCD. For example, if you have a few boards and you want to connect, for example, temperature sensor or display, and you don't know which hardware to use, or even library, the best way is to see which library are already written, and then buy, for example, appropriate embedded for this library. Let's take a look, for example, PubSub client library, MQTT. What do we see here? Like homepage, also compatibility. Also, there are two options to install library using command line, or even direct to download direct library. Also, each library contains examples how to use it. Here is the library JSON manifest. We see here the name library, keywords, location, version, examples, and developers can discuss here the problems or features of this library. The second feature of library register is examples. You can search, for example, one wire. We have a lot of different examples how to use it, or even Wi-Fi. For example, Wi-Fi. Also, you can list library by split by framework. For the mbed frameworks, you will see all the mbed libraries, different filters, like by frameworks, platforms, keywords, authors, and by different platforms. Okay, let's install the library using Eclipse. Sorry, again, back to Eclipse.
So a quick question for you, Evan, from Peter. Is it possible to use PlatformIO with ARM-CC and ARM link from the Kyle UVision 5?
Sorry, no, we don't have project generator for this idea. I will show. Sorry, I will switch again back. Like 1 second. Okay, no, sorry, I forgot to mention that we have. 1 second. We have the support for this idea, and the Peter asked about toolchains. It's no problem because he can use own toolchains and replace, but it depends on the build scripts. Currently, within PlatformIO 2.0, the build logic, like build scripts, are located in PlatformIO repository, but we have open issue in PlatformIO 3.0, where each developer vendor will have ability to create own development platform or fork existing platform and use own toolchain as Peter asked. But now only two options. To create own development platform, we have it in documentation, like custom platform. This way isn't easy, but it will allow to use own toolchain. Here is the list of our pre-compiled toolchain, but we don't have here a toolchain which Peter asked. Can I back again to Library Manager?
Okay, thanks.
Okay, and back again to Eclipse. Here we have a few subcommands, like the first command is install a library specific to list installed libraries. The Subcommander Register is very useful for developers which want to register own library in our registry PlatformIO, and uninstall update. For example, that's it. So start this library, or even, for example, if you are interested in Dallas protocol, for example, let's search for one wire. Sorry, need the quotes, but shell. You will search list. You see different library support. For example, let's install Dallas temperature library. We will install. You need to specify ID. The big difference between generic package managers or even library manager and PlatformIO is that we ask a developer to specify ID of the library. The problem here is that we have a few problems with trademarks. For example, we cannot use Arduino or like Arduino or even trademark direct into the name, because, for example, Arduino ask to use in the name, like, for example, one wire, but developers of the library developers don't know about it. And in this case, to eliminate these problems, we ask developers to use IDE, and we don't use this trademark names. Library, for example, Dallas temperature. You'll see that the Dallas temperature library was installed. Also, dependent library on where also installed. And I see that we have like, and the time is limited. Okay, and the last demo, I want to show the debug with PlatformIO. Let's close this project. I will use nuclear board and will demonstrate how to debug embedded boards using PlatformIO with Eclipse. Let's import. Oh, sorry, again, need to open. Let's open terminal. We need it. Okay. So let me open new project. Eclipse, 1 second. Eclipse starts. Okay. Now I will share the screen with Eclipse. Done. Now open terminal. Share terminal. Okay. Okay, and now open the project, debug, import. I have reconfigured project. From the debug. Okay. Here is the mbed example. Here is used mbed framework from the ARM, and we will try to debug this simple example. Okay, the first we should start hardware debug tool. Go to debug. 1 second, install toolchain. Again, as we see here, we use the third different development platforms where GCC ARM toolchain is used. Now we see the PlatformIO also downloads it because I didn't have installed it. 1 second. Okay, I will try manually to force it. 1 second.
So just to answer a quick question from Beck, this is exactly similar to what people could do if they were to develop directly from mbed.org using the online IDE, right?
Sorry, 1 second. I will stop downloading toolchain because quality is very bad. 1 second. Okay, so I will close Eclipse. 1 second.
Okay, so the question was, this demo is exactly, I mean, the code you're developing is exactly similar to what people could do using the online IDE at mbed.org, right?
Yes.
Okay.
Yes. Developer who use, for example, ARM mbed online compiler, they can use our ecosystem to build mbed projects. 1 second, I start again because what is more is that mbed has own built tool, name it IoT, but IoT depends on this CMake, and I'm not sure that this tool works everywhere. And we use own build system and own build script to build mbed framework. We don't depend on IoT or ARM. Okay. Okay. One second. Check. Good. Now. Fresh and so build. Okay, let's build it. You show you console. Okay, now let's upload this simple example to the board. Yes, my board is blinking now. And now let's try to debug. Okay, of course, not matter which platforms or framework will be used, PlatformIO generates proper project where autocomplete, code linting, and go to declaration works very well. For example, we have here different toolchain, different framework, but also have autocompletion. Go to declaration. Also, let's debug. Okay, run testing. Okay, and now start debug session. Okay, wait. Now let's open terminal. Command port. And let's try. Second. Okay, sorry. Try to reconnect board, maybe something. Didn't see the print. I will disconnect board. Oh, sorry, it's a different board connected to the board. And again, link. And now start debug. We have here a breakpoint near wait, and let's debug. Now it should work. And let's run monitor. And for example, start Again, we see hello world from PlatformIO. We can go again. Here is the disassemble again. And here we see the all features of Eclipse could be used in PlatformIO for professional debugging with embedded boards. Let's back to the our slides 1 second. So desktop and start. And finally, I want to say that also PlatformIO ecosystem has own IDE, which is based on the Atom text editor. It also has code auto-completion, code linting, multi-project workflow, different tabs, and what is interesting that PlatformIO command line is pre-built in this IDE and don't need to install separately PlatformIO command line. And I will try to show a few basic features of.
Just maybe just a quick reminder, Ivan, that we are running short on time. So
okay, no problem.
No worries. I mean, you can still make a quick demo of the IDE if you'd like.
It's like maybe let's to show simply. Okay. I will try to show a small window because we have my resolution is, and I will change. Sorry. And to show only this screen. And for example, we have also Blink project. Let's build. Also, we have here the same shell terminal PlatformIO completion. Also, there is ability to run specific environments because in previous example we use manually, but now we have instruments. Here is the powerful Seraport monitor with advanced settings, and of course library manager. Okay, I propose and one second. I switch again to the slides and we will finish on it. Oops. And the final slides is about PlatformIO ecosystem. It's more than 40,000 downloads per month. And here is the graph statistic with our user. We see that our community grows up extremely fast. Thank you. I'm glad to answer the questions if you have.
Thank you. So let's see if there are more questions. There were actually a few during the presentation, and you answered those. So quickly checking on Twitter. I don't see any questions. So maybe in the last 5 minutes we have, if you're still watching and you have questions, just shout them on meetup.com or tweet using the virtual IoT hashtag. Maybe in the meantime, Ivan, so what's the best way to actually get started with PlatformIO? Go to PlatformIO to the website and then use pip to install it, and that's it?
Yes. In our documentation, we have separate page like integration with Eclipse, where is detailed information how to generate first project for the Eclipse. And I hope that developers will not have any problems, because there are only two steps. The first to install PlatformIO command line utility, generate project, and then use Eclipse in generic way as developers do with Java or Python or C++. No difference here.
Okay. A quick question from Peter. When will PlatformIO 3.0 be released, or is this already available in beta?
1 second, I will switch the screen. Okay, sorry. The first, okay. I propose to look on the issue on the GitHub. We have like a milestone with PlatformIO 3.0, but now we are focusing to finish PlatformIO 2.0 and close all issues. And I hope like through 1-2 months we will have PlatformIO 3.0, because it's very complicated. Because it contains two hard issues. Like first, we are going to move all build scripts, toolchain frameworks to open source. Currently, build scripts, frameworks, and this logic are hidden inside within PlatformIO ecosystem in our repository. But we will create for each development platforms over the repository. People will see how a development platform works. They will have ability to fork or create own platforms. And what is interesting is that we will create the same like library registry. We will have platforms registry. In this case, developers, vendors will have ability in a few steps to create development platforms for new boards, for new MCUs, and integrate this PlatformIO. And the second option, and the second hard feature is a new library manager with semi-version dependencies, also ability to specify build flags within library.json, and the interesting feature is hardware debugging, which will be available for the most boards. And now we have seen only the debugging for nuclear boards, but we have aim to provide easy way to debug different embedded boards, which even doesn't contain hardware debug interface.
Awesome. There is a non-question from Adri, who says that he has no questions. He just wanted to send big compliments. PlatformIO makes life easier for many people. So a big thank you from Adri.
Thank you very much. It's okay. I cannot say like Ivan, because behind the PlatformIO is the PlatformIO team, and only community and developers, people forces us to make this PlatformIO 3.0. It's our community, like the stars on the GitHub. This statistic with downloads, new articles. This is the best effort, the best efforts for us.
Yes, exactly. So yeah, I think we're actually running out of questions and probably of time. Thank you again, Ivan. I hope many people will want to try out PlatformIO after this very useful presentation. It's going to be online on YouTube. So if anyone has any questions, so for people who are watching the video not live, and if you have any questions, just comment on the YouTube video, and yeah, I'm sure we will make sure to have them answered by forwarding them to Ivan and the PlatformIO team. So Ivan, thank you again. That was
also please excuse me for my English, because English isn't my native language, but I hope that people have understood me.
As I told you many times, I think, and I think our viewers agree, your English is perfectly fine, no worries. It was a very clear presentation. So thank you very much. Thanks everyone for watching. We will be back shortly. I don't think we have actually scheduled any upcoming virtual IoT meetup. We have a few in the pipe though, so just stay tuned and feel free to give us feedback by reviewing the group on meetup.com or commenting on today's meetup session. Thank you again, everyone, and bye-bye. Take care.